Welcome to the first of a few videos in which we are going to do a complete example of graphing a polynomial function. So I've got a few different examples to help keep the videos shorter. I'll try to do one per video. These are obviously not going to be exhaustive. There will be plenty of ways of factoring functions that we won't go through, but these should give a pretty good overview of the key tasks and steps we need to use in order to graph our polynomial functions. So we are going to start with the function f of x equals x to the fourth minus 32x squared plus 225. Now, take a moment, pause the video, and see if you could see what you would think what you'd have to do in order to get started. Meanwhile, I'm going to plug in my computer. It doesn't reach. Well, hopefully, the computer won't die before I finish this video. So, step one. And I'm definitely going to run out of space as we go through this example. So make sure you are judiciously using that pause button to write down as we go along if you plan to take notes on this video, which I highly recommend. Taking notes, as I've said in class before, engages more of your body, which engages more of your brain, which makes it more likely that you will make a lasting memory of the content, which not only leads to stronger learning, but easier mastery as well. Hashtag cognitive science. Step one is end behavior. We can also think of this as using our leading term test. So our leading term is x to the fourth. As you hopefully have already deduced, if we have an even exponent, both sides are going to go in the same direction. And since we have a positive coefficient, the right side is going to go up, which means naturally the left side is also going to go up. So over here, I'm going to make a quick note. End behavior, both sides go up. Then step two, and this step you could kind of do wherever. So let's do it now, is the y-intercept. And we find the y-intercept by plugging in x equals 0. So f of 0 is just equal to 225. So our y-intercept is 225. That, unfortunately, is the only point, unless we have a ridiculous amount of test values, that we can have at the right height without the use of calculus. With some calculus, we could find exactly where every high point and low point is just by using a few simple tools. Step three is zeros, multiplicity, and graph behavior. This is usually the longest of all the steps, just because it often involves the most amount of work. But this is all work we've done before. We have probably already determined that this is in quadratic form. So we can use our Xbox method to graph it. These are some pretty big numbers, so take a moment. Meanwhile, I'm going to look at the work I already did off to the side to say that this becomes negative 25 and negative 9. So we can now factor this into x squared minus 25, x squared minus 9, I'm anxiously watching the battery to make sure it doesn't die before the video ends. Anyways, for those of you who maybe haven't had me in class, this is not a surprising occurrence. So for our first factor, negative 5, positive 5, x minus 5, x plus 5. And then I'm going to skip through the work of factoring this next part, x minus 3, x plus 3. Now I want to make sure I have plenty of space to draw an actual graph. So I'm going to erase all of this, mostly. I need to keep my end behavior and y-intercept. And then I need to write our zeros, our multiplicity, and our graph. So x minus 5 is x equals 5. This is -5, positive 3, and -3. I'm writing them down here first because I want to make sure that I write it in numerical order up here. So numerical order would be -5, -3, positive 3, positive 5. The multiplicity for each of these is 1. And when the multiplicity is odd, is it going to be a touch or a cross? Pause the video, come back. And now that you're here again, thank you. Yes, it is a cross. So we have now finished step 3, which brings us to step 4, plot and label. Oh, this was not good. Let's see if a different marker will be more visible. Yes, here we go. Back in business. All right, so we need our y-intercept. I'm going to arbitrarily say this point up here is 225. I'm not going to make 225 little tick marks. So -1, -2, -3, -4, -5, positive 1, 2, 3, positive 4, positive 5. Unfortunately, I've experimented. The other colors don't show up very well, so I have to plot and label all in one color. If I were doing this on paper, I'd mix it up a bit. Look at the notes I've uploaded, you'll see a clearer example. So the zeros are -5, -3, positive 3, -5. The end behavior is up on the left, up on the right, and each of the zeros, I'm going to put a little C next to it because it's a cross. So starting from my leftmost zero, I'm going to draw the end behavior that goes up. Then I'm going to cross, curve back through, cross again, go up through my y-intercept, down to the next zero, cross, cross, and then go up. And with that, we have finished. I actually probably should have specified that step 5, for those of you who'd like it to be separate, is actually drawing the graph using the labels and the points that we plotted in step 4. So again, we start on the left with the left end behavior, and then we follow our labels to either cross or touch. In this case, all of them are crosses. Go through the y-intercept and then up at the end. Notice that we did not bother with the scale of this function, rather the scale of the graph. We go from -5 to +5, which is a distance of 10, but up and down, we go all the way to 225. So in pre-calculus, unless we make a lot of different test values to see just how low this point goes, we can't be more precise than that. If you're one of my students watching, this is as precise as I expect to see in the work you show me. If you are someone else's student, you should follow what they say, as they might want you to make some test values to have a more precise graph. My students will get to that in calculus next year, so I'm not concerned. Anyways, before my computer dies, I'm going to save this video, and I'll be back shortly with a few more examples.